Let's start with the formal definition of a linear combination. Let v1 to vk be vectors and c1 to ck be scalars. Then u equals c1v1 plus c2v2 plus up to ckvk is a linear combination of v1 to vk. A linear combination is combining scaled vectors. Think about cookies. Cookies are a combination of butter, white sugar, brown sugar, eggs, vanilla, baking soda, salt, flour, chocolate chips, and oatmeal. Different ratios of each give different cookies. Think of each ingredient as a vector, and the coefficients are the amount that will be used. I've been informed I'm not allowed to use oatmeal, so the oatmeal coefficient will be 0. For this recipe, I'll need 2 sticks of butter, 1 cup of white sugar, 1 cup of brown sugar, 2 eggs, 2 teaspoons of vanilla extract, 1 teaspoon of baking soda, half a teaspoon salt, 3 cups flour, and 2 cups of chocolate chips. These get added together and you get cookies. For a math example, let v1 be the vector 2, 1, 2, and v2 be the vector 0, 3, minus 1. Then 2, 4, 1 is a linear combination of v1 and v2. In fact, it's v1 plus v2. However, 2, 1, 0 is not a linear combination. In other words, it cannot be written in the form c1v1 plus c2v2 for any c1 or c2. How can this be, and how would we ever be able to tell? Well, we want c1v1 plus c2v2 to equal 2, 1, 0. Plug in the vectors and get 3 equations that we need to solve. This is lucky because we know how to solve things like this. Put it into an augmented matrix and reduce. Notice the bottom row would give the equation 0 equals minus 6, which is not true, so there is no solution. Or we can say 2, 1, 0 is not a linear combination of v1 and v2.